Hello, and thank you for joining me. In this session, we'll be talking about recursion. Now, one of the benefits of recursion is that it allows for more dynamic coding. So let's take a look at what recursion is and how to use it. For the first example, we're going to use the slide that we're looking at now. So if you look at the slide, you'll notice that it has a brief description of what recursion is. And recursion is a process that a procedure goes through when one of the steps of the procedure involves invoking the procedure itself. That means it calls the entire procedure. A procedure that goes through recursion is said to be recursive. Now, notice this final sentence because this is the actual recursive statement here. Let's take a look at a visual example of recursion using this slide as an example. And this is what happens when we actually execute that line. Notice it calls the entire slide. And with that slide comes the brief description, and it also brings that recursive statement. And this repeats, and it continues going on and on and on. And a recursion will continue infinitely until we either run out of room or we have some sort of conditional statement that ends it. Keep in mind that it's this last sentence, the one that calls the entire slide, that's the recursive statement. That's what's driving these recursions. Now, another visual example of recursion is when two mirrors face each other. The image created is similar to our slide here. In the case of the mirror, the recursive procedure is the event we perceive as reflecting. That's just another way to visually think of recursion. Okay, so now we have a better understanding of what recursion can look like. So now we can think of what would recursion sound like. And typically we come across this in a conversation with a chatty individual, someone who talks a lot, they'll start a story, and they'll constantly segue into another story. And right about the point where you just can't stand it anymore and you don't want to hear another word, you can think of that as a Stack Overflow error. This person has bombarded you with story after story after story and has never finished the previous story. And this can be a very unpleasant experience, not only for us, but when we do something in our coding, it can be a very unpleasant experience for the program that we're writing. So in this case, we come across what's called a Stack Overflow error. Now we have a better idea of what recursion can look like and what recursion can sound like. So what we're looking at here is how recursion is implemented in our code. We start by declaring a variable just so we can follow along with what the code is doing. Below that is a procedure, which I've gone ahead and named recursive procedure. Now, what I want you to notice is here at this line where it says call recursive procedure. So our code is executed line by line, and the first line is changing the value of the variable, and the second line is actually calling the procedure in its entirety. So whenever we actually get to this line, it's going to call this whole procedure, put this current instance of the procedure on hold. It's going to put it away in a stack or a call stack, and it's going to start a new instance of this procedure. Because the lines of code are executed one by one, and we always have this interrupt, this other call recursive procedure line in here, we never get to this final line right here, which actually ends the procedure. So this will continue infinitely or until we run out of room. If you remember, I said that the previous instance of this procedure is put away in a stack or a call stack. These procedures will continue recursively until we run out of stacking room. To give you a better idea visually, think of it this way. Look at how our code is written. Because the line in sub is never executed, ending the procedure, it never happens. So the procedure is left open. We keep going from one recursion to the next, and it keeps adding to our stack. This is how our code is written. And if you look over here, this is how it's actually executed. So if you look, we start with the recursive procedure. It begins. We go through our first step. We call the recursive procedure. Again, it calls the entire procedure. And it keeps going and going and going. So this is actually what's happening. So this is a good way to visually think of your procedure stacking in the stack area. Now, as I mentioned before, this stacking will continue until we run out of room. And by room, I mean the stack area. So much memory has been allocated aside for recursive procedures. Now, it depends on the size of the procedure. It depends on the programming language you're working in. There's all kind of variables that determine how much room or how many recursive procedures you can have. In this particular case, for my computer, for the language we're working in, this particular procedure right here will go about 6,800 instances before I hit a Stack Overflow error. And when that happens, that's just saying that we can only run this recursion so many times before we run out of room. So again, the thing to be mindful of, this is how it's written, but look how it's carried out. each recursion stacks on the previous recursion. So what we want to do is we want to address this potential problem. Now, as you can see over here on the left, we have our procedure that's going to continue until we hit an error. It's going to go on indefinitely or until we get an error. Now, if you notice over here, remember, we're keeping track of this X value. What I've done is I put a conditional statement in there. And what I've said is that once X is equal to or greater than 3, we're going to exit this procedure. And so what ends up happening is that the procedure, we get our value of 3, our procedures exit it, we go back to the previous instance of this procedure, and we go through the same process again. And you're going to see that here. So with our new code on the left, with our conditional statement that after 3 recursions, we're going to go ahead and exit out of this. If we look over to the right, we see how it's actually executed. We have our procedure. It calls the recursive procedure again. We go through again, and then we hit this value here where X is equal to or greater than 3. We've met our conditional statement. We exit out of the sub. It goes down to the next line of code, goes through the process, and ends that sub, or ends that instance of the procedure. Once that one's ended, we go back to the previous instance of this procedure, and it keeps going down the line until we end all the previous instances. Again, depending on how your code is written. The point I want to make here is that recursive procedures or recursive statements will continue infinitely until you either get a Stack Overflow error or you have a conditional statement in there that allows a recursion to end. All right, so I've talked about this Stack Overflow error, and here's an example of it. So when a program tries to use more space than is available on a call stack, that stack is said to overflow. And usually this results in a program crashing or other problems. The idea, it is an error that we want to avoid. So recursive procedures are often set to end when a certain condition is met. If that condition is never met, then the recursions will continue stacking till the space allocated for them is used up. And remember, when we end one instance of a procedure that's recursive, it's going to go back to the previous one and it's going to continue down the line where it left off. So you also need to be mindful that wherever your condition statement is placed and whenever it ends, what's going to happen afterwards, because that's what's going to happen for each instance afterwards.